What if I told you that time isn't what you think it is, and space isn't either? For centuries, we believed time ticked the same for everyone, and space was just an empty stage where the universe played out. But in the last 100 years, science has revealed a much stranger truth. Space and time are fused together into one cosmic fabric called spacetime. Spacetime bends, it stretches, it ripples, it even slows down. It may hold the key to unlocking the deepest mysteries of the universe, from black holes to time travel. So today, we're counting down the top 10 facts about spacetime that will blow your mind. Fact number 10. Space and time are the same thing for most of history. People thought of space and time as totally separate. Isaac Newton believed space was like a giant, invisible box where everything happens. Time ticked away like a perfectly synchronized clock for everyone, everywhere. Then, in 1905, Albert Einstein shattered that idea with his theory of special relativity. He showed that space and time are not independent. They are woven together into a four-dimensional fabric called spacetime. What that means, your position in space, where you are, is always tied to your position in time, when you are. Move through one, and it changes how you move through the other. Space-time isn't a backdrop. It's an active part of reality itself. Fact number 9. Time moves differently for everyone. Here's a wild one. There's no universal now. If two people are moving relative to each other, they don't agree on what's happening at the same moment. This is called the relativity of simultaneity. Imagine two lightning bolts striking opposite ends of a train at the exact same time. A passenger on the train might see the front bolt first, while someone standing outside sees both strikes as simultaneous. Both perspectives are correct, because in space-time, simultaneity depends on motion. In other words, time isn't absolute. Your now may not be the same as mine. Fact number 8. Time dilation is real. If you move fast enough, time literally slows down for you. This is known as time dilation. Its famous twin paradox illustrates it. One twin goes on a spaceship, traveling near the speed of light, while the other stays on Earth. When the spacefaring twin returns, they'll be younger than their sibling. Their clock ticked slower because of their high-speed journey. And this isn't just theory. In 1971, scientists flew atomic clocks on airplanes and compared them to clocks on the ground. The moving clocks really did run slower, exactly as relativity predicted. Today, GPS satellites orbiting Earth have to correct for time dilation, or your phone's navigation will be off by miles. So yes, time travel to the future is possible. All you need is speed. Fact number 7. Gravity bends space-time. Newton thought of gravity as a mysterious force pulling objects together. But Einstein showed it's much stranger. Gravity is curved space-time. Imagine space-time as a stretchy rubber sheet. Now, place a heavy ball in the middle. It makes a dent. Smaller balls roll toward it, not because the big ball is pulling them, but because the sheet is curved. That's how planets orbit stars. They're not being pulled. They're following the curves in space-time created by the star's mass. So, next time you drop something, remember, it's not being tugged down by an invisible force. It's sliding through the curves of space-time. Fact number 6. Light follows curves too. If space-time is curved, then light, traveling at the fastest speed possible, has to follow those curves too. This leads to a phenomenon called gravitational lensing. When light from a distant galaxy passes by a massive object, like a cluster of galaxies, space-time bends the path of the light. To us, it looks like the distant galaxy is stretched, warped, or even duplicated. This effect is so strong that astronomers now use gravitational lensing as a cosmic magnifying glass, letting us see galaxies billions of light years away that would otherwise be invisible. In space-time, even light cannot go in a straight line if the universe does not want it to. Fact number 5. Black holes are space-time monsters. Black holes are regions where space-time is curved so much that nothing, not even light, can escape. At their center is a singularity, where density becomes infinite and the known laws of physics break down. The edge of a black hole is called the event horizon. Once you cross it, you're cut off from the rest of the universe. What's stranger is what happens to time near a black hole. To an outside observer, your clock slows down dramatically as you approach the horizon. You'd appear to freeze in time. But to you, time feels normal. You just fall right in. Black holes don't just trap matter, they trap time itself. Thanks to Stephen Hawking, we know they may not last forever. Through a process called Hawking radiation, black holes slowly leak energy and could eventually evaporate. Even space-time monsters have a life cycle. Fact number 4. Space-time can ripple for decades. Scientists believe that if space-time is flexible, then cataclysmic events, like black holes colliding, should send ripples across the universe. These ripples are called gravitational waves. In 2015, the LIGO Observatory finally detected them for the first time. The signal came from 2 black holes merging over 1 billion light years away. The collision was so powerful, it briefly released more energy than all the stars in the universe combined. Gravitational waves are literally space-time ringing like a cosmic bell. And now, we can hear the universe in a way we never could before. Fact number 3. The universe is expanding. In the 1920s, astronomer Edwin Hubble discovered something shocking. Galaxies are not just moving around in space. Space itself is expanding. Imagine drawing dots on a balloon, then blowing it up. As the balloon expands, all the dots move away from each other. Not because they're traveling, but because the space between them is stretching. That's our universe. This expansion means the universe had a beginning, the Big Bang, about 13.8 billion years ago. Space and time themselves erupted into existence in that moment. Fact number 2. Dark energy shapes space-time. If the universe is expanding, you might expect gravity to slow it down. But in 1998, astronomers discovered something shocking. The expansion isn't slowing down, it's speeding up. This mysterious push is called dark energy. We don't know what it is, but it seems to make up about 70% of the universe. In other words, most of space-time is dominated by something invisible, something we can't explain, but something powerful enough to shape the fate of the cosmos. Fact number 1. Space-time could be the key to everything. Despite all we've learned, space-time is still a mystery. General relativity explains it on cosmic scales, while quantum mechanics explains the tiny world of particles. But the two theories don't agree with each other. Somewhere, a deeper theory of quantum gravity must exist. Ideas like string theory or the holographic principle suggest that space-time itself might not be fundamental. It could emerge from something even more basic, like information. The ultimate theory of everything may not just explain space-time, it may reveal what reality itself is made of. Conclusion. So what have we learned? Space-time isn't just an empty backdrop. It bends, it stretches, it ripples, it expands, it creates black holes, fuels the growth of the universe, and maybe even hides the key to the ultimate laws of nature. The most mind-blowing fact of all, we don't live in the universe. We live in space-time, the very fabric of reality itself. That's our journey through the top 10 facts about space-time, from time dilation and black holes to the expanding universe itself. We've seen that space-time is not just a stage. It is an active, dynamic fabric shaping everything we know. If you enjoyed this deep dive, make sure to like the video, subscribe, and hit the notification bell so you don't miss future explorations into the mysteries of the cosmos. But now, I want to hear from you. Which fact blew your mind the most? Was it the idea of time slowing near a black hole, or the possibility that space-time itself might not even be fundamental? Drop your thoughts in the comments below. I'd love to know what you think. Thanks for watching, and remember, we don't just live in the universe, we live in space-time itself. Until next time, stay curious.